Next up is Katie Stockton Roberts from the BBC. Who doesn't love the BBC? Come on, I spend half my life on that website and the other half watching it on TV. Katie's going to talk about, the BBC is another one of these organizations with a long and illustrious history of technology. So she's going to talk about how we use microservices to revamp and reinvigorate legacy systems. Katie, thanks very much.
Thank you. Hi, yes, I'm Katie Stockton Roberts, and I'm here to talk to you about microservices in the wild, or how BBC are moving across to using microservice architectures. First off, a bit about me. I've been a developer for over 10 years now. I've worked at the BBC for 5 years. I started out as a JavaScript developer working on IPTVs, or the new generation smart TVs, making the BBC Sports app for the Olympics. And I worked on BBC News and BBC Music as well. And I'm now development lead for Knowledge and Learning, which is one of the BBC's divisions. And I work on sites like BBC Bite Size, BBC Food, and Terrific Scientific, which is a new site which is getting kids 9 to 11 interested in science. So has anybody here not heard of the BBC? It is awesome that I get to go anywhere, and the BBC's been there before. You're probably familiar with the BBC televisual output like Top Gear, Doctor Who, Sherlock, and I know Netflix has bought Peaky Blinders, so they're showing that. The BBC is advertising free, so we're funded by a national TV licence. So we're not a commercial organisation, we don't have any sponsors, but it does mean that we can put the audience at the heart of everything we do. The BBC has a remit to educate, inform and entertain. So the TV is the entertainment, the news is the information and the inform, and Knowledge and Learning, which is my team, we're the educate. The BBC is across multiple different locations, so we have 24,000 people employed by the BBC worldwide, and around 1% of those work in the development section, so that would be the digital section, so that's developers, testers, product and project within that area. The BBC has been around had a digital presence online since 1997, and this is what we used to look like, and nothing screams 90s design like that. If you look closely, there's drop shadows everywhere and beveled edges. Now we look more like this. So in terms of what content we do, we push over 10,000 new media items are published online in a week. We have products that run across the 4 screens, so PC, TV, tablet, and mobile. And we support over 1,000 different devices. Our audience numbers, right. A site like BBC Food will get around 3 million unique users a week, which is about the population of Utah. So that's like everyone in Utah going on and checking out a chocolate cake recipe. A big site like BBC Sport will get close to 30 million viewers a week, which is the population of Texas plus Arkansas. I've been on Wikipedia this afternoon. And we're separated out into different teams. So I work in Knowledge and Learning, but there's sport and there's children's, and we sort of operate as almost like indies working under a big umbrella, creating stuff, but we're all moving towards the same goal. Previously, we worked with lots of different development languages. For a long time, we were using Perl, some of the obscure TV languages like MHEG. More now, we tend to use Scala and JavaScript and Node. So, anyway, microservices in the wild. This is a picture of the wild. This is not a microservice, it is a micro-rhinoceros. And does anybody know who the guy is? That's Sir David Attenborough, sir. He's a national treasure. So yes, how the BBC is moving across to using microservices. So I'm going to talk about a product I know pretty well, and that's BBC Bite Size. BBC Bite Size is an educational tool. It's aimed at children between 4 and 16 years old, so it's there to support them throughout their school years. And it's also got teacher content on there as well. It first launched in 1998 when Thomas had a full head of hair. And it's been around in its current form for the last 10 years. It covers a lot of content on there. So within there, we've got 4 different educational systems because the 4 nations in the UK have different educational systems. We have 38 different subject areas with 300 separate programs of study. We've got over 5,000 topics of study and over 5,000 revision guides on the site. So we've got a lot of content on there. And 82% of all 15 to 16-year-old exam students in the UK say they use BBC Bitesize. At exam time, which is sort of the start of exam time is now, till the end of June, we pull in around 3 million unique users a week. That drops off as soon as the summer holidays arrive and everybody doesn't care about school. It's also, the code base itself is a bit of a monolith. This is one of the pictures that you can Google on monoliths, like was mentioned in the last presentation. It's not a new code base. Some of the code base there goes back to around 2010. It was written in PHP, and it's getting difficult to add new features to it. So when you add a new feature, you have to run a full regression pack of tests on it, and that is becoming more and more complicated as the product gets bigger. The release process isn't great. It's on our old BBC server farm, which means we have to raise tickets to an operations team to release the product. And because it takes a while we can't run stage and live on the same day, so we have to release across different environments. We have to release to test, then to stage, then to live. Packaging up RPMs and putting content in tickets, it takes a long time to do. It can take weeks to get new features out to the audience. And as a developer, that's not really a fun place to be. We've got slightly reduced capacity because there are only so many handles you can get on this code. So you can't have a large numbers of developers working on this code base at any given time, because if you do, you end up with the problem that you start getting into merge conflict hell. So single monolithic code bases do not necessarily scale to large number of users, and they don't necessarily scale to large numbers of developers working on it. So let's take a look at our monolith. So it's a standard N-tier architecture. It's written in PHP. I've got a couple of things on here. iSight is our content management system. Nitro is our API where we get our media playback information. It's a data-driven website, like I mentioned before. We also use another BBC service called Acme. Acme is our games management engine, and we use it within Bitesize for quizzes and mock exam questions, which are really useful for kids during the exam period particularly. And around 2012, the Bitesize team started to move towards a more microservice-based architecture. And in order to do that, they had to think about what components can we start breaking away from this monolith. So what exists in isolated functionality that we can take away, not pushing it into our current code base. So where we started was we looked at a problem, and we identified a problem that we had. So Bitesize has some unique problems that it has to solve that the rest of the BBC don't have to really worry so much about, especially because we need to use equations for maths and science subjects. For that, we use latex formatted strings, but we tried using external services to create the equations for us, but it didn't work because iSight, the content management system, was too different. They didn't play nicely together, and also the services that existed out there didn't cover everything we needed. I think it was long division and long maths were not covered by the existing services. So what the team did is we built a microservice called Equation Chef. And Equation Chef renders the latex strings, and it works by sending requests to latex packages, which then creates PDFs of the formula. So here we go, this one here. And we've got PDF. We then convert it into a PNG with a transparent background, which is understandable by our content management system, and everything can just work together. So we've got our first little microservice there. It's existing independently, and it can start to evolve at its own rate. We then looked for other problems, and there was another problem because iSight didn't really have the capabilities and functionalities that the editorial team wanted to upload assets such as infographics. This is an infographic from the drama course telling you how to show dominance. So they built a service called the Binary Asset Manager. This is back when we were giving our services very meaningful names, so BAM. And it allows us to upload binary assets and manages them for us. It uploads them to an S3 bucket, and then the iSight service can access that S3 bucket and give us the information, and Bitesize can render those into the page. We also have another, more of a macro service than a microservice. This is the LDP, or the Linked Data Platform. It's a BBC-wide content management system, and we use that data to enrich the bite-sized content. So where next sort of links, programs of study that are tied together with that information that we're getting from that. It's modelled on the national curriculum structure, and it programs and topics of study which are important to the student that's learning about thermal decomposition, and all the guides that they should be reading on as well. We've still got our N-tier architecture, but it's slightly less cluttered with functionality because we've started to create microservices around. But at the minute, it isn't broke. So it works. It's worked for a long time. We know that it works for our audiences as it was. So why would we even think about changing that? Why would we think about going through the process of trying to move from that architecture to a new architecture, and what benefit would that show to our audiences? So we did get some audience feedback that bite size was becoming difficult to find relevant content, because like I said before, there's a lot of content on there. And what I want to find might be, I'm studying my GCSEs in England, and I want them to be presented to me in Welsh for some reason. So it's difficult to find relevant content to what I need to know, and there's no way of mapping content to different exam boards at the minute. So the concept came up that we'd build something called the Bite Size app. So this is a mobile app, and these were the requirements that came through from our product were, as an exam student, I want to be able to personalise bite-sized content to my need, to be able to choose my country, language and exams, and to have bite-sized content in a shorter form that's easier to digest for my exams. I want to be able to test myself on what I've learned and see how well I'm revising. That's why I had to read that from the screen, because that's exactly what our product owners said they wanted. This is what I saw as a tech perspective. What we need is an iOS and Android front end. We're not going to make it in Windows app because we just don't have enough users. We need a data aggregation layer. We need it to be highly personalised, which means we need a mandatory sign-in service. We've never had a mandatory sign-in service before at the BBC, which is why it's an elephant in the room. And we have a really tight deadline. So they came up with this idea, and we had effectively 4 months to build it. The reason we had 4 months to build it is because we needed to get this out before the Easter holidays, because at that point, that's when our GCSE students become really ready to revise for their exams. It's when they need that content. So we had this, and we had to build everything in parallel. So to start off with, this is our bite-size application. So it's the N-tier architecture again, but I've just spread it out a bit differently and forgot to put Nitro on there. Sorry. And it's housed on the BBC server farm, like I said before, with a few services already on AWS. And here is our mobile user. Our mobile user is going to be on either an Android or an iOS device. And this is when we come across our first problem. The mobile user is not going to be able to process the data in the same way as the bite-size app does at the moment. As you can see at the moment, the bite-size app is taking data from an awful lot of places, and then it's doing a lot of the data aggregation inside the app itself. So it's doing a lot of thinking. If we're going to replicate that in 2 different mobile builds, that means we're going to be having that logic in 3 different places, which is very unscalable. Also, and very complicated. It'll also bloat the size of the apps, which we don't want to do, because we want to keep these apps fairly lightweight to be able to be good for downloading for students, so they're not using all of their mobile space up with the app. And also, we don't want them to be having to pay for data calls all the time as well, because every time I make a data call, if I'm on 3G, it's costing me money. We don't want to be charging our kids for learning if we can help it. So what we decided to do was we said we'd create a service called Einstein. Einstein will present JSON content to the apps in the right format. So Einstein needs to get is a little node microservice which is powering the data for the app, and it needs to get data from all these different areas. So what we did then was we used something that is a BBC service called Morph. Morph is a cloud-based excuse me, I just got a drink. It's a BBC-produced, node-based cloud system. It fetches data from other sources and runs operations on it, on that raw data, and makes the output for those operations available for consumption. It was created originally for the sport team, but it's service agnostic, so it's one of the opportunities that we had with to use one of the other teams' thinking to help power our stuff. And because it's come from sport where they have very, very large numbers, it also came with great caching benefits, so they'd already solved a lot of our problems around caching. Morph is also a TV character from the 1970s and 80s, so that's one of the examples where we use one of the product names after the TV shows. So Einstein is getting its data from Morph. It's not just acting as a pass-through for the data from Morph. It's also working on the versioning. So if I'm using a different version for Android and iOS, if I'm sending up different information for those, Einstein controls that and also handles the error processing and generates the appropriate formatted response. So next we've got personalization. BBC also has a service for this, BBC ID, and that we're lucky we can use that to manage our users' credentials, so we don't have to worry about data protection issues because they're already doing that for us. So we can use the hashed user ID that we get from BBC ID. And with that, we can store user data in the user activity service. User activity service is, again, it's a key value store which has been developed by another team within the BBC, and we can store our content in there, but we can't store it in long form. We can only store shortened codes in there because otherwise we'll bloat that system. So in order to get the information that we need from the user activity service in a meaningful format for the mobile app, we created another microservice called Newton. Newton takes content from the user activity service, rehydrates it with data from Einstein, and then provides the app with a digestible, personalized data content that can be used and tested in isolation. Now, at this point, we could have actually done that in Einstein, but we chose not to because it's a separate enough concern. So rather than making Einstein into a new monolith, we're keeping the separation of concerns there. It's two different microservices working at different paces. Also simplifies testing. It simplifies development. Newton took a month to build, and I think Einstein took 2.5 months. So again, we had a very limited time span, and that ensured that we kept those cycles right down. They're both AWS services, which means they can scale up when they need to, because it's very important that we don't start 500 during exam periods, because if you've got an exam tomorrow and you want to do some revision, you need to have that product and it needs to be working. So where do we go from here? So this is as it was. We can move from our NTM monolith to a more microservice-based architecture. And could we do something like this? Could we, using all the same data providers that Morph is getting all the data and aggregation, could we use Einstein in the same way to power the bite-sized web, in the same way it's using to power the bite-sized app? So that would look kind of like this, with us getting the information through Einstein. And then we just have a presentation layer rather than a full PHP application, which makes it easier to transport into the AWS area. But what we're actually doing is something more like this. We're using Lambdas and the API gateway to start building our pages, and they're contacting Morph directly rather than using Einstein, because Einstein is doing one job and it's doing one job well for the mobile app, so conflating it with too much information. This was just a better solution. And James Constable will be producing a paper on this soon about how they've done it. And I'll tweet that if anyone's interested in it. Just to say that from the talk that was first thing this morning, that isn't the exact architecture. What the real architecture does look like is that, which is, like you were saying, it's much more complicated than what it is, but it shows all the different services that are talking to each other. Something about team size. One of the conferences I went to, they said, well, of course you can do all this sort of thing. You've got thousands of developers at the BBC, which isn't actually true. And we've got fairly small development teams in knowledge and learning. We have a total of 14 developers across 2 sites. And for the building of Einstein and Newton, we had a feature crew of 3 developers, 1 dedicated tester, and a business analyst and a product owner who worked just on that product. So to do a bit of summing up, what's good about microservices? We can get faster development. We can build and deploy independently. Products evolve at their own pace. We can release little and often, isolating changes for identification of and quick resolution of problems. Simplifying testing of products. So when we're testing Newton, we're only testing Newton. We don't have to worry about having an understanding of everything within the whole world of it. We run a zero bug backlog as well. So if we do find something, we fix it, or we decide that we're not going to fix it. We don't have a massive bug backlog of things we'll fix when we get around to it. We do spend 60% of our time writing unit tests, behavior tests and integration tests. We work closely with our testers now to do those, so that we're not writing tests just for code coverage sake. We're making sure we're writing tests with the thought pattern in mind of somebody who doesn't just want to follow the happy path, which developers tend to do. We can allow our products to be built in development languages which is suitable for them. So whilst we tend to use Node, we have got other services such as one called Lovelace, which is built in Java, and we're creating black box APIs that other teams that want to integrate with, that they can do so. Moving to microservices is not without problems. We're a DevOps team, so what we build, we support, and we build a lot, so now we have to support a lot. We've gone from being a web development team to having to be full stack developers, and we've had to become system administrators, and it isn't for everyone, the whole T-shaped people thing. Have to learn more than one system. So previously, you'd become an expert in a monolith. You'd bathe in that monolith. You'd know that monolith backwards. Now we've got lots and lots of different microservices. You can't be an expert in all of them. We try to mitigate against that by having coding styles and coding standards. We spend a lot of time discussing codes that's been written by the remote team and vice versa, so that we know where we're at, so the DevOps team feel comfortable supporting those products. Costs, AWS costs, server farms don't. We didn't see those costs before, and now we do. And you've got to be careful, because it's very, very easy to spin out of control with your AWS costs if you're not watching them. Security. Has anybody here ever had the problem where somebody has checked one of the API keys into GitHub? Yeah, I knew I wasn't alone. And IAM roles being too permissive. We've had junior developers accidentally deleting stacks and things like that. We've had to learn to be much more vigilant around those sorts of things that were invisible to us before. Microservice setting up the infrastructure. We're having to do that many times, and although we're getting really good at it, it still takes time, and we can get that time right down, but we've still got to go through our information security paths. We still have to go through our monitoring reviews. We still have to go through our runbook and operations reviews. And that all takes time, and it's a lot of admin overhead, usually, that falls on the development lead. And we're responsible for all our products, so we are on call all of the time. One of us will always be on call from our teams, but that does create the mindset that we have to build more robust systems. So, in all, I'd say that the move to microservices for us has been beneficial, and it hasn't been rocket science. But if you want to learn about rocket science, we do have a page for that. That's one of the terrific scientists pages. Okay. Thanks very much.
Questions for Katie? This is a real-world microservice implementation.
Will you be open sourcing any of the Einstein or any of the services you have out there?
Oh, sure. Will we be open sourcing any of the Einstein or the Newton services? The BBC has tried to open source some of their things, but it is quite a difficult process. It's not something that the BBC is used to doing yet. There is pressure to try and go that sort of way, but at the minute, it's yeah, we're still a bit of a closed shop, I'm afraid.